Welcome back to the highlights from the past 25 minutes symposium. I'm joined here by Samuel Omlin from ETH Zurich, and you organized the symposium on Julia for HPC, Reproducible High Performance Computing. Tell me more about this. Julia, that's different from Fortran. Why should we use Julia today?
Well, Julia was designed to solve the two-language problem. It was some researchers at MIT who thought, okay, all the time we develop, for example, in MATLAB or in Python, and then afterwards you want to run it on a supercomputer and get good performance. What we have to do, we have to translate. Or nowadays, also there are a lot of libraries, of course, C++, etc. So we have to make some wrappers, maybe try to figure out a way to connect these two, like Python and C++, and it's a cumbersome effort. And Julia now solves this problem by allowing to use just one language for both, for the interactive development of prototypes, and then to have a statically compiled code that can run as fast as C++, etc.
And it's also a fully open tool, right? And that's why it's gained quite a lot of popularity even in the HPC community lately. So this certainly sounds worthwhile. Can you tell me more about the mini symposium? Were there any obvious highlights here?
Yeah, so this was the fourth year of the mini symposium, and every year we try to invite different speakers. And this year, well, we chose as a topic reproducible scientific high-performance computing in order to align well with the overall conference, of course. And so we had different talks relating to this, but each one was on his own topic also super interesting. And so we had one speaker talking about how we can address graph core IPUs from Julia. And this is something that basically no other language allows to do. Then we had a talk about how we can do singular value decomposition in a way that is completely that abstracts it completely such that we can run it on GPUs, etc., for different vendors. Then we had also a talk about how we can generate performance tests from unit tests. And all these talks related then back to this general topic of reproducibility of both scientific results, but also performance.
And that is important. There's a lot of talk in the community about, the general reproducibility crisis in scientific computing, right? So if I'm a student, or for that matter, a professor, and I've never touched Julia before in my life, but I would like to get engaged in this community and start using this on my HPC resource, what should I do? Should I join you, or what's the obvious next step here?
Well, so if you're a student at ETH, then we have a course there that is called Solving PDEs Using GPUs with Julia. And so that is a super solution to get started. And besides that, if you're at another university, then there is a lot of material out there. Also at CSCS, we have given courses already twice, inviting Tim Besar, who is the lead developer from CUDA.jl. And in any case, just start to reach out and you get very quickly into a very nice community.
And then we can hope that you're going to organize more of these highlight sessions that I can come back to PASC 2026 and see some cool examples. Samuel, thank you so much for joining us, and thanks for this hard work, and thank you.
Thank you very much.